A beautiful welcome to all of you guys. It is a Tuesday afternoon and you are sitting with me, Utobile. Thank you so much to Liberty once again for sponsoring the show. Truly guys, none of this would have been happening. And remember, grade 12s, do download the Tenfold education app if you haven't done it yet. This is the app where you can send through all the questions. So with today's problems, it did come through the Tenfold education app. Another thing, grade 12s, I know you guys are working hard. Please continue to work hard. Physics is on Friday and you write paper 2 on Monday. So let us prepare well. Ask me as many questions as you can and I will answer it to the best of my ability. And as we answer, I will also teach a few lessons here and there in case you got lost in your classroom. I will show you nice tips on how to remember certain things. So make sure you have a notepad, you have a highlighter with you, and then we're going to start working. So we are doing only paper 1 because you do write paper 1 on Friday. So with today's question, the first question that I have is on electric circuits. Now remember, electric circuits, let's take it back. It's a topic that started actually in grade 10. And then as we build up from grade 10, grade 11, and grade 12, there's a few trends that you need to learn to answer any problem in electric circuits. The first thing is you need to look at the circuit whether it is series or whether it is parallel. Now remember, if a circuit is in series, we have the 2 resistors or a number of resistors that are attached next to each other. Resistors in series, it means the same current will pass through this resistor and through this resistor. Resistors in series have got the same current, right? But resistors in series are potential different dividers, which means it will have a different voltage, and then we can add it all up. However, when we have resistors in parallel, it's a different ballgame. We have current that will be singularly, it will split between the 2 resistors depending on each resistor's resistance, right? But the potential difference for resistors in parallel is then the same. So resistors in parallel are current dividers, but the potential difference remains the same. Now you must always keep that in your back of your mind if ever you have to answer a question that has both parallel and both series. The minute you know that, you can answer any problem in electric circuits, and I'm going to show you how. This is the first question that we have. This is question 9, and we are told that a battery with an internal resistance, this is very important because already when you see the word internal, you do know that you're going to have the small r in whatever equation. Now with internal resistance, it's not something that we learn in grade 11. In grade 11, we do learn electric circuits, but internal resistance is something we don't really do. We as teachers, we touch on it a little bit, but in grade 12, it's full on internal resistance more than grade 11. If you do have a good foundation for grade 11, this should be a piece of cake because the formulas do change and they only just add internal resistance. So we have internal resistance of 1 ohm. Now, you can see that small r there, that means internal resistance. The big R then means resistors. The normal resistors that we are using, like this one will be a 20 ohm resistor, 8 and 16 and so forth. And we have an unknown EMF. The EMF is unknown. So most of the time they'll tell you, okay, the EMF of the battery is 12 volts or 20 volts and so forth. Then you know the EMF of the battery. In this case, the EMF is unknown. However, we do know the internal resistance of this battery. We must keep that in mind. And it is connected in a circuit. Now let's look at the circuit. I can see that 8 and 16 are parallel to each other. The sum of 8 and 16, if we calculate the total resistance for resistors in parallel, will then be in series with 20. Remember, if we were to add these 2 together, they become 1 resistor. Then the current will go past here, the same current will pass through the 20, only if we do add these 2. Going on. If we name this X, just for argument's sake, if resistor X and 20 are now in series with each other, it means they are then in parallel with resistor R. Then you're going to say, Tops, why do you say that? The same current will come flowing through, and then the current will split. It will divide, rather, into the different forms of the resistors, right? So we'll have current moving through, and then the current will join again, and it will then move into that direction. So keep that in mind. Just take that all out so that it looks a bit more neater. So then we have a high resistance voltmeter, which is connected across the battery. This is the voltmeter that they're talking about. We've got A. Remember, A represents an ammeter. An ammeter, we learned in grade 10, that is a device that measures the current within a battery. So we've got A1 and A2. We've got 2 ammeters. We can see that the current that passes in 16 and 8 will collectively pass between A and move to 20. However, we do not know whether the ammeter readings on this one and the ammeter reading on this one will be the same because we do not know what the resistance of resistor R is. Another thing to remember, when resistors are in parallel, it doesn't necessarily mean the current will split equally. The current will split depending on what each resistor technically requires. So because R is unknown, we cannot assume that the current in A1 and A2 is then the same. We do know that the total current in A1 and the current in A2 collectively will give us the total current within the circuit. Because remember, once the current splits and then it comes back together, it moves then as one. So A1 and A2 will give us our I total for the current inside the circuit. So this is represented, A1 and A2 represents the ammeters of negligible resistance. Let me just take this off. So now let's just go through our theory one more time. The theory to help you answer any question in electric circuits. We've got 8 and 16, which are in parallel. We do know that resistors in parallel have got the same potential difference. So whatever the potential difference is at 8, it will be the same potential difference at 16. Collectively, 8 and 16 and 20, the potential difference here at the top will then be the same for the potential difference here at R. Why? Because these are resistors in parallel. The current that splits between 8 and 16, the total of that current will give us the total amount that we will then find in A1. So technically, that's all our rules that are moving along. Another thing to also keep in mind, we have a switch S here which is closed. It's very important to remember what happens when the switch is open and what happens when the switch is closed. Just like in a nutshell, if you have the switch S which is open, so imagine this as being a switch, the switch is closed, the electrons or the current is really flowing, and then we open the switch. Now remember guys, electrons can't jump, right? So they can't go woo over to the other side, woo over to the other side, So we actually open that and then the current doesn't really move, right? Because the switch is open. So keep in mind what happens when the switch is then closed and when the switch is then open. They love asking you a question. What will happen to the voltmeter reading if the switch S is then open, right? And then obviously you have to use the formula to explain what is going on. But you must keep in mind, switch S being open and closed really does affect the reading on the voltmeters, ammeters, and so forth. So keep that in mind. So let's see what questions do we have? So it continues to say, with switch S closed, now we know that current will be flowing. The current passing through the 8 ohm and is 0.5 amperes. So here we have it. At the 8 ohm resistor, the current that will be here will then be 0.5 amperes. Now, before I answer the question, let's delegate. I've got my resistance, I've got my current, I can find my potential difference. Remember, I can use R is equal to V over I. I can then find what V is. That is my voltmeter reading, right? My potential difference against around the 8 ohm resistor. Now remember, whatever the potential difference will be for the 8, it'll be for the 16. Why? Because resistors in parallel, the potential difference will be the same. So for 9.1, let's answer that first then. 9.1 says we must state Ohm's law. We already are given this information, so I do know somewhere, somehow, the information will then come along. So let's answer 9.1. Now, they do ask for Ohm's law in words. Remember, if they ask you to define something, it must be the words exactly as it is. So for Ohm's law, it says the potential difference across a conductor is directly proportional to the current in the conductor at constant temperature. Now, if you do want to use a different wording, where you can say directly proportional to the current to the conductor, removing the last bit, you can say provided the temperature. Let me just write it for you. So any memo will have either or. provided temperature and all other physical conditions are constant. So this is then what you should have for Ohm's law. The potential difference across the conductor is directly proportional to the current in the conductor at constant temperature, or the potential difference across a conductor is directly proportional to the current in the conductor provided the temperature and all other physical conditions are then constant. Now it depends which one your teacher taught you, and you can then use that one. Let's see for how many marks was this. This was then again for 2 marks. I just want to stress something else, guys. Even though you kind of sort of had Ohm's law, but you didn't use the correct wording, the examiner cannot answer it or mark it right. Remember, when you have to give a definition or define the laws or the phenomena of physics, you have to use the correct language. Because if you say Ohm's law is when resistance is directly proportional to the potential difference but inversely proportional to the current, you are explaining something. Your explanation and a definition is not the same thing. So make sure you know all your definitions off by heart. Remember to practice, write them down, use the correct wordings because examiners are looking for certain words, right? They do not mark explanations, they only mark definitions. And like I always stress to my children, you cannot fail because you were lazy to read. Remember, this is the part of theory that requires you to sit down with your textbook, read through the physics, and actually absorb all that knowledge. So let's look at 9.2. 9.2 says we need to calculate the reading on the ammeter. Remember, ammeter means current, so we need to know how much current is then actually passing through A1. Now remember, if we are able to find what the potential difference is at 8, we can find the current. Tops, why do you say that? I'm already told that the current here is 0.5 amperes. If I can find the potential difference for these two, the total current at 8 and 16 collectively is what we will find here at A1. So I'm going to do it step by step with you guys. Remember, when you're answering such questions, make sure that the examiner knows where it starts and knows where it's going. So we are looking for A1. I just want to write here so that you know what's happening. I just want to draw a little picture for us here so that you know where I'm coming from and where I'm getting everything. We have the 8 ohm resistor here at the top. We've got the 16 here. They are resistors in parallel. I am further told that the current passing here, let me just make an arrow, is 0.5 amperes. So let's continue. I'm going to start with the 8 ohm. I'm looking for the potential difference at the 8 ohm resistor because whatever the potential difference is at 8 will be at 16. So V is equal to IR. I just want to write here on the corner. If you are getting confused, the initial formula is R is equal to V over I. I just made V the subject of the formula. Remember what you do. You put I over 1. You cross multiply. So V times 1 is V and R times I is RI. So that is where I got this formula. I'm looking for the potential difference of 8. I am told that the current at the 8 ohm resistor is 0.5 and the resistor in question is the one which is 8. So let's use a calculator. I can probably do that in my head though. If I say 8 times 0.5 will give me 4. So the potential difference around the 8 ohm resistor will then be 4 volts. But then remember, resistors in parallel are current dividers, but the potential difference is the same, which therefore means the potential difference of the 8 ohm resistor is equal to the potential difference on the 16 ohm resistor, right? Resistors in parallel are current dividers, but the potential difference will be the same. Therefore, I can say that if I'm looking at the 16 ohm resistor, I'm going to say IR over here. I'm going to then find the current. Let me just continue to say this will also then be equal to 4 volts in case you are getting lost. This is where I get the 4. The potential difference will be the same. I take the same potential difference over here. It is a 4 over here. I am looking for the current that will pass through my 16 ohms. Remember, in question, we've got A1 here. We want to know what is the total amount of current that will be at A1 and what will the reading be at A1. I'm looking for I. The resistor in question is then 16. Now it's just mathematics. I'm looking for I to be by itself. You divide both sides with what is bothering what you're looking for. In this case, I want I to be by itself. I divide both sides by 16. 16 will cancel on this side. I'm left with I by itself. Let's see what we get over here. I'm going to have 4 over 16 Therefore, I get a reading of 0.25. So the current, 0.25, remember the SI unit for current is then amperes, which means the current that will pass through the 16 ohm resistor is 0.25. But remember what they said, they're looking for the total reading of A1. All we have calculated is the current at 8 and at 16. Remember, the current will move and then the current will join and then move together. So we're not done. Let me just see how many marks was this question actually. So this question was going for 4 marks, so which means you have to work hard on this one. So now I need to say I total. And I always say, I love it when children actually indicate that I'm saying I total now. It makes it so much easier for the examiner. If you want to really be fancy, you can take it further and say the current on the 8 ohm resistor plus the current on the 16 ohm resistor. Then the examiner knows, they figured out that the A1 will be a sum of 8 and 16 of the current together. So at the 8 ohm, we had 5. This was given to us, plus we just calculated 16, which was then 0.25. Let me get a total there. So I've got 0.25. I'm going to say plus 0.5, and then I get 0.75. 0.75. Remember, the SI unit for current is amperes. It's a capital A, my darlings. A small a means acceleration. So there we have the current, which is now going to pass at the reading that will be in A1, right? The trick to this question was we had to first figure out, where we had the most information was on the 8 ohm resistor. Finding the potential difference, we could then say the potential difference on the 8 ohm resistor will be the same as that in 16. And then we can say, we can then find what current will pass through the 16. Collectively, these two, as the current moves and joins, it will pass on the A1. That was one way of doing it. I do have another way of doing it. Let me show you that one. So it really now depends on what then works for you. Let me see if I don't have space here. Let me try work here on the side so we can use the same drawing. Let me just use a different color. So what you could have done, remember this is resistors in parallel. I could have said R parallel. Remember these two lines, they show that you're doing resistors in parallel. I've got R1. This is an indication of the number of resistors that you actually have. And then I'm going to say I've got 1 over 8 plus 1 over 16. Now with this method, there's two ways of also doing it. You can do the reciprocal or then do the inverse. I'm going to do it the long way around, just in case we've got a grade 10 who's also watching, so you guys don't feel confused. 1 over 8, I'm going to say plus, that will be 1 over 16. And then I'm going to get a reading of, let me just leave it as a fraction, 3 over 16. I nearly made a mistake. 3 over 16, and then you do the tip and tap. Remember, the denominator becomes the numerator, and the numerator becomes the denominator. Let me put this in my calculator. So this becomes 16 over 3. Oopsie daisy. Okay, let me use a fraction. 16. At the bottom, we're going to have a 3. And then I need to have 5.33. Remember, always to 2 decimal places. I'm going to have 5.33. Remember, the SI unit for resistance is then in ohms. Just want to show you another trick. If you do know it, you're more than welcome to use it in this part over here. If you take this part over here in your calculator, you put this in brackets, you just say -1, it will then give you exactly this answer. So if your teacher has showed you the long method, stick with that. If your teacher has shown you the short method using the -1 as an exponent, then you're more than welcome to use that one. So now that I've got the resistance there, I can therefore say I'm looking for the current in the parallel part of the circuit. Remember, I will have 4. How did I get 4? 4 is the potential difference that I found for the resistors in parallel. Remember, the potential difference for resistors in parallel will then be the same. That is where I got this 4 from. All over, the total resistance for the resistors in parallel will be 5.33. So let's see if I can find if we do get the same answer. Okay, let's just minimize that. So here I'm going to have 4 at the top over 5.33. I should get 0.75. Voila! There we are. So the current will give us 0.75. Remember, the SI unit for current is then a capital A. Now we found the total current within the circuit. This method, starting from here, We just have to find the total resistance for resistors in parallel, and then we have to find the current for resistors in parallel, having the potential difference at the top and then the resistance at the bottom. And as you can see, for both of them, we get 0.75 on this side and 0.75 on this side. So it really doesn't matter how you want to do it. I always say, do it how you understand it. For me, it makes sense to say, use the rules of physics and say the potential difference will be the same, find the potential difference, then find this one. But if you are more comfortable using a quicker, simple way and knowing the principles of this method, you are more than welcome of doing it. What I always say, do not try to figure something else or try something new. Do what you know, and then it's much more easier. Remember, you write for 3 hours for 150 marks. You do not have time to waste, and you need to make sure that you write efficiently and you actually pace yourself. So choose any method that works for you. So let's look at the next question. Let me see what's our next question. This one is for 5 marks. And this question says, if device R, remember device R is the one that is unknown, so we do not know the reading on device R. We are, however, told that it delivers a power of 12 watts, right? We need to calculate the reading on A2. Before we start reading or answering, I want us to delegate. Let's find out, what do we know now? We just found out that the reading of A1 will be 0.75. How did we find 0.75? We took the total current at A and 16, added it together. It's the same current that will pass at A1. Now the question asks that we need to find the reading on A2. Now let's think about this. If we were to find the total resistance, so we have the total resistance of this one, but now this one will be in series with the 20 ohm resistor. If we can find the total potential difference of the resistors here on top, we do know that this section here will be in parallel with resistor R. What do we know about resistors in parallel? That the potential difference here at the top will be equal to the potential difference here at the bottom. So it means we can use that law or principle in physics or of electric circuits, and then we are able to find the reading of A1. So let's take it away and let's try answer it like that. This question is 9.3. 9.3. I want to do it the long way around again. I just want to draw a little diagram so that everyone knows where we are. We have an 8 ohm resistor here. We have a 16 ohm resistor. This is in parallel. We have R, which is unknown. And remember that this is then in series with a 20 ohm resistor. Okay, we have A2 here that we need to remember. So now let's answer what the question says. They want us to find out what is the reading of A2. So this is what we're first going to. We're first going to find the potential difference of the resistance, which is 20. Why am I going to do that? Because 8 and 16 will be in series with 20. Resistors in series mean that the potential difference is not the same. Right, so that's where we're going to start. I'm going to then say R, I'm looking at the 20 ohm resistor, is equal to V over I. My R is, or the resistor in question, is a 20 ohm resistor. I'm looking for the potential difference over. What is my I? Remember, we had A1 there, and the reading of A1 was 0.75 amperes. We got that by adding the current passing through the 8 and the 16 ohm resistor. We got 0.75 over here, and now it's just mathematics. Remember, this is over a 1. If you have a whole number fraction on this side, you cross multiply. V multiplied by 1 will give me a V, and then I'm going to have 20 multiplied by 0.75. So let's see what my potential difference is here. So I can just say that times 20 then gives me 15 on the dot. Remember, to 2 decimal places. So my potential difference for the 20 ohm resistor gives me 15, and the SI unit for potential difference is then a capital V. However, we are not done, right? We need to find the total resistance. Remember, just want to put an invisible, an imaginary potential difference that was there. Remember, when we calculated the potential difference on this parallel circuit, we found that it was 4 volts, which then means that V parallel total means for the ones on top. Resistors in series, we have to add the potential difference. So the potential difference in this section, we're going to add with the potential difference of this one. Collectively, they're going to give us the potential difference that is equal to the potential difference around R. This is resistors in parallel. Now remember, for the 8 and 16, we found that it was 4 volts, plus for the one for 20, we just calculated, which is 15 volts. This we can do in our head. So that will be 19 volts. So an imaginary voltmeter there means that R will also have a potential difference of 19. I can therefore say the potential difference of the parallel is equal to the potential difference of R, which will give you, I just left V there, will give you 19 volts, right? Because these are resistors in parallel are equal, but we're not done yet. The question further told us that if the power that is delivered by resistor R is 12 watt, what will the reading of A be? So we are not done. Looking at your formula sheet, you can find a formula which you are looking for power, you've got your potential difference, and you have to find current. One of these formulas that you can use is P is equal to VI. I've got my power, I'm told that it can deliver power of 12 watt. The potential difference was calculated, which is 19. Remember, how did we get 19? The potential difference here at the top will be equal to the potential difference on R. Why is that so? The potential difference for resistors in parallel is the same. If the potential difference for the resistors here on top is 19, it means it will be the same thing for R. I am looking for the reading on my I, which is my ammeter. I'm going to divide both sides by 19. Remember, you have to divide by the number that is disturbing the alphabet that you're looking for. 19 and 19 will cancel. I'm going to be left with I on this side. Let's put this on my calculator and see what we get. So I'm going to have 12 over 19. Let's see what my reading is. So I'm going to get 0.63. Remember, if the 1 was 5 or greater, then the 3 would have changed to a 4. Remember, in physics and chemistry, we always round off to 2 decimal places. In this case, I'm going to have 0.63. 0.63. And then remember, the SI unit for current is then a capital A. Small a means acceleration. So that is then the power delivered by resistance R. Let's see what we have. Our next question. For 3 marks, we must calculate the reading on the voltmeter when switch S is now open. Switch S is open. We have to calculate the reading on the voltmeter, which is now this voltmeter in question. Now remember, we've got internal resistance, we found our potential difference, we found our current, right? Now we know that the current that we just calculated in A1 is 0.63 amperes. Now we've got 0.75 current at the top, we've got 0.63 current at the bottom. Collectively, they come together here and then they move as one, which means I'm going to add this one and add this one as the total current in the circuit, right? And then therefore I can then find my reading on my potential difference. So let's calculate that one. So this question is 9.4. Switch S is now open. Now you can use a formula where you say E is equal to I, then you have your big R plus your internal resistance, right? So you can say, remember you've got 2 resistance, you've got the V terminal or external, and then you've got your V internal for internal resistance. The potential difference for external was 19. That was for the 2 resistors, the 2 parallel parts of the circuit. Internal, we've got the current, which is 0.75 plus 0.63. Remember, the internal resistance of the battery is then 1. Let's see what we get when we put this in our calculator. I'm going to put it exactly as it is. Remember to always put brackets amongst your stuff. I'm going to say 19 plus open bracket 0.75. Plus 0.63. You don't have to say times 1. Anything multiplied by 1 remains itself. So I'm not going to do that one there. So I get 20.38. 20.38. Remember, the SI unit for potential difference is then a capital V. Another way that you could have looked at it, remember, it really does depend on what you understand and what you prefer. You could have said your V internal, which is then equal to your current and your internal resistance, which is the opposition of flow of current offered by cells and batteries themselves. That is your small r. I know that my internal resistance, I know there was a 0.75, which came from the 8 and 16 ohm resistor, plus the A reading on A2, which came from the resistor R, which was not known, which is 0.63. 0.63, my internal resistance in the battery is then 1. Let's see what we get there. Remember, there's many ways to kill a cat in physical science. 0.75 plus 0.63. I'm not really going to say times 1 because anything multiplied by 1 remains itself. So here I get 1.38. I just can't make it. There we go, 1.38 as a decimal. 1.38, the SI unit for V is a capital V, right? Then I can say my E is equal to V terminal. And then I can say V internal. Remember, you find this on your formula sheet. The terminal was 19 for the top and the bottom part of the resistors in parallel. Plus, I just calculated the internal, which is 1.38. This we can do in our head. 19 plus 1 will give me 20, and I'm left with 38. The SI unit for I will then give me a capital V. And as you can see, this method over here is a little bit longer than this one, but it really does depend on what do you know and what do you understand. But as you can see, both answers are the same. So now remember, like what I always say, use your structure, use your diagram, and then look at the feel, think of all the principles and laws of physics, and then that is then how you attack the question. Let me see if we have another question for this one. Calculate the reading on voltmeter S. So we've just calculated that one, and that's all the questions that we have for this one right over here. So I think before we move on to our next question, I think maybe let's go for an ad break, and when we come back, we'll do a little bit more on paper number 1.